Hello students, let us read the question. Upon spotting an insect on a twig overhanging water, an archer fish squirts water drop at the insect to knock it into the water. Insect is located along a straight line path at an angle phi and distance t. A drop must be launched at a different angle theta naught if its parabolic path is to intersect the insect. If phi is equal to 36 degree and d is equal to 0.9 meter, what launch angle theta naught is required for the drop to be at the top of the parabolic path when it reaches the insect. So the key concept involved here is the projectile motion. Here we are going to use some standard formulas for range and the height of the projectile motion. Let us suppose if a particle is projected with initial velocity u at an angle theta with the horizontal, then the value of this is the range and this is height. We can directly write the formula for the range is equal to u square sine 2 theta upon g, and the height formula for the height is equal to u square sine square theta upon 2g. These are the two formulas, standard formulas that we are going to use to solve this question. Let us first understand what is given in the question. This is the archer fish. And this is the insect. The distance between them is d and the angle with the horizontal is phi. Now the archer fish want to bring this insect down into the water. For that it will squirt a water in a parabolic path. This will be the path. So in the question we have been given that the insect is hit at the maximum height of the parabola. So this will be equal to range upon 2, because if we draw an imaginary path of the squirt, if it doesn't hit to the insect, it will be like this, and this complete value will be equal to r. Therefore we can say that by the time it reaches to the height, it will cover range by 2 distance in the horizontal direction. From here we can write r by 2 is equal to, this distance can be written as d cos phi, and if we use the standard formula for the range, it can be written as u square sine 2 theta naught upon 2g. This, if initial velocity is u and the angle with the horizontal is theta naught, we can write in this way. Let me write it again. d cos phi is equal to u square sine 2 theta naught upon g upon 2g, which is equal to r by 2. This is our equation number 1. And for the height, we can write the value of height as d sine phi, and by using, this is the value of height d sine phi, and by using the standard formula we can write the value of height is equal to u square sine square theta naught upon 2g. This is our second equation. Now from the equation number 1 and 2, if we divide these two equations, here we can divide equation 2 dividing equation 2 by 1, we will get d sine phi upon d cos phi and equal to u square sine square theta, theta naught upon 2g, and by dividing the this part of the equation 1, which is equal to u square sine 2 theta naught upon 2g. Let us simplify this equation. We will get tan phi is equal to sine square theta naught upon, if we write this is equal to sine 2 theta naught, let me write sine 2 theta naught is equal to 2 sine theta naught into cos theta naught. We are going to use this sine 2 theta formula here. So we will get tan phi is equal to sine square theta naught upon 2 sine theta naught into cos theta naught, which will be equal to 1 upon 2 tan theta naught. From here we can write that the value of sine theta naught is equal to 2 tan phi. Now let us put the value of phi is equal to 36 degree, which is given in the question itself. So we can write this is equal to 36 degree, and if we need to find out the value of theta. Theta can be written as tan inverse 2 tan 36 degree, which is equal to 55.4646 degree. So our final answer theta value of theta naught is equal to 55.4646 degree. This is the angle of the projectile motion. Thank you so much.